So for our project, we are using two mutual funds. The first one being Guggenheim Alpha, or SAOCX, with a 5-year return at 3.5%, standard deviation for risk at 8.66, and a minimum investment of 2,500. And the second fund is the Hennessy Cornerstone, or the HFMDX, with a 5-year return of 6.34%, standard deviation for risk at 23.8, and another minimum investment of 2,500. And we're going to invest a total amount of 20,000. So for our variables and objective functions, we have X as the amount invested in Fund 1 and Y is the amount invested in Fund 2. And for our expected 5-year return, we have it at 0.035x and 0.0634y. And then for our risk and our standard deviation, we have 8.66x and 23.8y. So for our constraints, we have the same minimum amount invested for each fund, and X and Y being the amount invested for each fund. So Fund 1 is greater than or equal to 2,500, and the same goes for Fund 2. And then the difference between the two cannot exceed 25% of the total amount invested. So X minus Y is less than or equal to 5,000, and Y minus X is less than or equal to 5,000. And then the total amount of money that needs to be invested in both is X plus Y is less than or equal to 20,000. This graph represents our investment into both mutual funds. We have X representing the first fund, or the amount of the first fund, and Y representing the amount we put into the second fund. And when we graphed our equations and our inequalities, we have a feasible region with 5 corner points. So solving the corner points, how do we get the corner points? So for point 1, we're using line 1 and line 2, and we solve them to get the intercept. X is 2,500, Y is 2,500. And for point 2, we're using line 1 and 4 to get the intercept 2,500, 7,500. And for point 3, we're solving line 2 and 3 to get the intercept. X is 7,500, Y is 2,500. For point 4, we're doing the same thing, but with line 3 and line 5 to get the intercept. 12,500 for X, 7,500 for Y. And then for the last 1.5, we are solving line 4 and line 5 to get the intercepts 7,500 for X, 12,500 for Y. So for our optimization points, right here what we're doing is we're finding out how to maximize our returns and also mitigate our risks. And so what we're doing is we're taking those 5 corner points that we got from graphing out our feasible region, and we're plugging those corner points into our objective functions. And so the return objective function was 0.035x plus 0.0634y for the returns. And then the objective function for the risks was 8.66x plus 23.8y. And as you can see here, the expected returns go the highest when we plug in the third corner point, or the third corner point, and the risks are the lowest when we plug in the first corner point. And we'll summarize what this all means in the conclusion. So in conclusion, you can see that when you plugged in that third corner point into our profit objective function with 7,500 in Fund 1 or X and 12,500 in Fund 2 or Y, it'll return us the most, but it's also the riskiest, and it uses our entire funds when we do that. And so when you also saw on the last slide with the optimization points that the one with the least amount of risk was that first corner point plugged into our objective function for risk was 2500 in X and 2500 in Y. It works out that way from the equation, but you can also see that, if you're investing less, if you're putting much less in, your risk will also be much less. And as it says there, after weighing all the options, we've decided that the distribution of 2500 and 7500 best represents our investing goal of earning the maximum profit. And here are just some lessons from each of us that we have come to learn and understand from completing this project.